Welcome to SCI-EASE. In this video, I am going to discuss a very important topic of class 11th chemistry, that is electronic configuration of elements. We have done Aufbau principle, Pauli exclusion principle, and Hund's rule. And we know what are the rules which govern how to fill the electrons in the orbitals. So according to Aufbau principle, the orbitals, they are arranged in order of their increasing energy, and we have concluded that one S subshell that can have the maximum of 2 electrons. First, I will tell you the sequence. 1s, it has the lowest energy. Then comes 2s, 2p, 3s, 3p, 4s, and 3d. Then we did Pauli exclusion principle. There we studied that the maximum number of the electrons which the orbital that can have, they are 2. So S, it will have 2, 2s again 2. In p subshell, there are 3 orbitals, okay? And the maximum number of electron in each orbital, that can be 2. So here P 6, 3s 2, 3p 6, 4s 2, and 3d, D subshell has 5 orbitals, and each maximum number, I am telling you that the maximum number of the electrons that can be accommodated in D subshell, that is 10. So D10. Okay. Now, when I discussed Hund's rule, I discussed the electronic configuration of some elements, that is from hydrogen to neon. That you can see from that video. I will take up first hydrogen just to begin with. Hydrogen has atomic number 1. So the first orbital, that is 1s, it will have 1 electron in it, S subshell, and this is the electronic configuration of hydrogen. Then comes helium, then lithium, beryllium, boron, carbon, nitrogen, then oxygen, then fluorine, and then comes the neon. Okay? So what is the electronic configuration of neon? It will have 1s2, 2s2, 10 electrons. They are there, atomic number 10. This is the atomic number, in fact. So 2p, 6. So how many electrons? 6 to 8 to 10. So neon, it will have fully filled p subshell, and its electronic configuration is this. Now next, come to sodium. It will have 11. 11 is the atomic number, 11th number. So it will have the configuration of neon first, 1s2, 2s2, 2p6. And the next electron that will go in which subshell? It will go in 3s. So it is 3s1. Okay, clear? You can write this configuration of sodium, magnesium, or aluminium like or this can be written like core of neon, because it has 10 and then 3s1. This is another way of representing the electronic configuration, okay? And this is the elaborated method. Now, magnesium 12, 1s2, 2s2, 2p6. So this is configuration of neon. And now the next electrons, they will go in 3s2. So it will also be fully filled in case of magnesium. Now, next is aluminium with atomic number 13. So you write up to 12, 1s2, 2s2. You will enjoy doing this. 2p6, 3s2. Now the next subshell, that is 3p. So the one electron that will go in 3p. Here you will represent it like this. Or you can write this configuration as neon 3s2, magnesium, in case of magnesium, here neon 3s2, 3p1. This is another way. Now come to silicon 14. Now you will enjoy. This is 1s2, 2s2, 2p6, 3s2. Now 3p, how many electrons? 2. Here it is 1, here it is 2. Come to phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3. It's half filled p subshell. Now next is sulfur with atomic number 16. So what is the electronic configuration for this? 1s2, 2s2, 2p6, 3s2, 3p4. One electron that will be paired. We will fill the orbitals according to Hund's rule. First, the electron, all the orbitals, they will be singly occupied. Like in the case of, if I am drawing this 3p orbital here. So first, they will singly occupy orbitals. And then here, the pairing that will take place. 1, 2, 3, and this is 4th. Okay? This you must know. Sometimes you have to draw the orbitals also. So you will show how the electrons, they are filled in the orbitals. So chlorine is 17. It is a halogen. 1s2, 2s2, 2p6, 3s2, 3p5. Okay? Now next is again inert gas, noble gas, you can say argon. Here P subshell will be fully filled. So it is 1s2, 2s2, 2p6, 3s2, 3p6. So these are 18 electrons in argon, and here also the like neon, here 2p6, here 3p6. Now come to this potassium. Next is potassium. What you see? Here the next electron, that will go in 4s, not in 3d. because due to this Aufbau principle, according to Aufbau principle, 4s has lower energy than 3d. This we know. So the next, here we can write like the configuration of argon, 18 complete, and the next electron that will go in 4s subshell. Okay. In case of calcium, argon, configuration of argon 18, 22. So here this is 4s subshell is also fully filled. Now come to scandium. These are transition elements, and here there is D subshell also. We will start filling the D subshell. Now what is the configuration of this? I will write argon. This you can write like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, 4s2 and 3d1. So how many orbitals are there in D subshell? There are 5 orbitals. 1, 2, 3, 4, 5. So the electron will go here. Now come to titanium. Here argon, 4s2, 3d2. The second electron that will go here in the next orbital. According to Horn's rule, all the orbitals, they will be singly occupied first and then pairing will start. Okay. So come to vanadium, argon, 4s2, 3d. Three. Okay, 3d3. Now again it will go here. Come to chromium then. It is Ar, 4s2, 3d4. Okay, but this is not correct. Here there is an exception. It is an exception here. Here we know that half-filled orbital, half-filled configuration and the fully filled configuration, they are the most stable. Here what is the result? One electron of 4s, I will draw here. Argon, you will draw up to that. Then it is 4s and this is D subshell. Okay. According to this configuration, it is like this. But this is incorrect. It is stable. It is fully filled, so it is 4s is stable. But here this 3d is not stable. If this electron that will be shifted to this orbital and 3d is now having half-filled configuration. So this configuration is more stable than the previous one. So this is an exception. You must learn this thing. You keep this thing in your mind because many times chromium, write the electronic configuration of chromium, or I will tell you about copper also. That is also the exception. Mainly these elements are given in the exam. So this is here the configuration that will be 4s1, 3d5. Okay. The reason is that this is more stable due to half-filled D subshell. Now come to manganese, argon, then 4s 2, okay, and 3d, here 3d 5. Here also 3d 5. 4s2, 3d 5. Now iron 26. Now the pairing will start. 4s2, 3d 6. Pairing that will start here. I am drawing only the D subshell. 1, 2, 3, 4, 5 and 6. Clear? Now come to cobalt. Ar. This is the configuration of argon. We have written the core. 4s2, 3d 7. So here one more electron that will go in this orbital. Come to nickel. It is Ar, 4s2, 3d 8. Now come to copper. Copper 29 atomic number. Here again configuration of argon up to 18 electrons. Okay. Now next is 4s2, 3d 9. But again this is an exception. Here also the configuration, this configuration is wrong. The right configuration is 4s1, 3d 10. Here again, what is the result? I will show it here. This is 4s, and here the d orbital, that will be the electron from this. Initially I have written like this: 3, 4, 5, 6, 7, 8, 9. It should be like this, but not. This is this electron, it will shift here and it will become like this, and the configuration of copper is 4s1, 3d 10. So the configuration of chromium and copper, that is very, very important. Now come to zinc, argon, core configuration. 4s2, fully filled 4s subshell and 3d subshell. So this is the electronic configuration of elements up to 30 atomic number. These are very important. You should know them, know the method of writing the electronic configuration. One thing I want to tell you here, that sometimes in exams there is question, write the electronic configuration of F negative. What do you mean by negative? That one electron that is added to fluorine. This means it will show the configuration of neon. Okay? Sometimes cations or anions, they are given. Okay? Chromium or copper, nickel, any sodium, Na positive, that is given. Na positive is given. Mg2 positive is given. Then you will write the configuration of neon in that case. So you must know what are cations, that you know that when the element loses the electrons and it will acquire the positive charge, and when it gains the electron, element gains the electron, it will acquire negative charge. So sometimes the electronic configuration of cations and anions is also asked. So you should know how the cations are formed, how the anions are formed, and what electronic configuration you are to write. I think the things are clear to all of you. So I will meet you in the next video with another topic of class 11th chemistry. Till then, thank you very much.